Good morning, children. Let us see the next question. Question number 18b. It says, there are 6 boys and 3 girls in a class. An entertainment committee of 5 is to be formed such that there are 3 boys and 2 girls. So, in that committee, there would be 3 boys and 2 girls. And those 3 boys will be selected out of 6 boys, and these 2 girls will be selected out of these 3 girls. Okay. In how many ways can the committee be formed? Number 1. Number 2, what is the number of ways if there is at least 1 girl in the committee? So there are 6 boys and 3 girls. Out of 6 we have to take 3, and out of 3 girls we have to take 2. Okay. So for the first question, entertainment committee with 3 boys and 2 girls can be formed in this manner. Okay. 6C 3 into 3C 2 ways. Okay, that means 60 ways. Now in the next question says, if there is at least 1 girl in the committee. Okay, that means you cannot have less than 1 girl. Okay, you can have more than 1 but not less than 1. Okay, so minimum there should be 1 girl. So entertainment committee with at least 1 girl can be formed in, so we can have either 4 boys, 1 girl, or 3 boys, 2 girls, or 2 boys, 3 girls. Okay, but we cannot have less than 1 girl. Okay, so 6C4 into 3C1. Okay, when you take sum, it's coming 5. 4 plus 1 5, 3 plus 2 5, 2 plus 3 5. Okay, 6C3 into 3C2 plus 6C2 into 3C3 ways. Okay, so you just solve, you'll get 120. So 120 ways you can select a committee where at least 1 girl will be there. Okay. Next question 24. In an examination paper on business mathematics, there are 14 questions divided into 3 groups. Okay, 3 groups of 5, 5 and 4 questions. Let's say there are 3 sections, A, B, C. Okay, A has got 5 questions, B has got 5 questions, and C has got 4 questions. Okay, a candidate is required to answer 6 questions, taking at least 2 questions from each of the first 2 groups and 1 question from the third group. Okay, so there is a condition that in total the candidate has to attempt 6 questions. Okay, and he or she has to do at least 2 questions from A, at least 2 questions from B, and at least 1 question from C. Okay, so how many ways, so in how many different ways can he make up his choice? Okay, so choices can be of this type, like the candidate can take 2 from A, 3 from B, and 1 from C. Okay, or 3 from A, 2 from B, 1 from C. Okay, or he can take 2, 2, 2 from each. Okay, so let us see. The required number of ways a student can attempt the 6th question is, from the section A he can take 2, from section B he can take 2, and from section C he can take 2. So 5C2, 5C2, 4C2, because in section C there are only 4 questions. Then next choice can be 3 from A, 2 from B, 1 from section C. Okay, and the third choice can be 2 from A, 3 questions from B, and 1 question from C. You just solve it and you'll get the answer. Question number 16, 2 of part C. A cricket 11 is to be chosen from 13 players, of whom only 4 can bowl. Okay, so there are 13 players. Out of 13, 4 can do the bowling. Okay, and in how many ways can the team be selected so as to include at least 2 bowlers? Okay, so here out of 13, 11 players have to be selected. Okay, but the condition is at least two bowlers should be there. Okay, at least two bowlers should be there, and in total how many bowlers are there? Four bowlers are there. Okay, so what we can do is at least two bowlers means they can be two bowlers or three bowlers or maximum four bowlers. Okay, so let's see. A team of 11 players is to be selected such a way that at least there must be two bowlers. That is, there could be more than two also. Okay, total players 13, out of which four are bowlers. Then remaining are non-bowlers. So this is how we can select. We can select two bowlers and nine non-bowlers, or we can select three bowlers and eight non-bowlers, or we can select four bowlers and seven non-bowlers. Okay, so we can select in this manner. You just solve it and you'll get the answer. Question 17. Out of 3 books on mathematics, 4 books on physics, and 5 books on chemistry, how many collections can be made? Okay, if each collection consists of exactly one book on each subject. Okay, and next, at least one book on each. So let's see the first one. Here we have got 3 maths, 4 physics, and 5 chemistry. So in the first one is saying exactly one book on each subject. Okay, so if I have to select one math book, okay, only one math book out of 3 maths, so that selection can be done 3C1. Okay, and then one physics out of 4 can be done 4C1, one chemistry can be done 5C1 ways. Okay, so number of required combination will be 3C1 into 4C1 into 5C1. Okay, so that will be 60 ways you can select. Okay, the books such that exactly one book of each subject is there in that collection. Okay, next, at least one book on each subject. At least one means one or more book. Okay, so here when we are selecting books, I can select one math book or two math book or three math book. When I'm selecting physics, then I can select one physics or two or three or four. Same way for the chemistry, one or two or three or four or five. Okay, so one or more than one maths book can be selected how many ways? 2 to the power. How many maths book available over there? 3. So 2 to the power 3 minus 1. That means 7 ways. Physics book can be one or more physics book can be selected in 2 to the power 4 minus 1 ways. That means 15 ways. One or more chemistry book can be selected in 2 to the power 5 minus 1 ways. That means 31 ways. Okay. So therefore, the selection of one or more books can be done in this. Okay. Number of maths. Okay. 2 to the power 3 minus 1 into 2 to the power 4 minus this for physics into for whatever you have got for chemistry. So you get 3255 ways you can do that selection. Okay. Now next is question 18.1. Out of 7 consonants and 4 vowels, how many words can be formed, each containing 3 consonants and 2 vowels? So here 7 consonants are there, 4 vowels are there. Now how many words can be formed, each containing 3 consonants and 2 vowels? Okay, so firstly we will find how many words, how many selections we can do. Okay, how many selection we can do for 3 consonants and 2 vowels. Okay, together. So how we can do the selection of 5 letters where 3 will be consonants and 2 will be vowels. So for that we will use combination. So firstly find number of different combinations having 3 consonants and 2 vowels. So number of such combination will be 7C3 because 3 consonants have to be selected from 7. Okay, and 2 vowels we are selected from the given 4 vowels. So 7C3 into 4C2. But here we are looking for the words. Okay, how many words we can have? So in those combination, okay, in each combination, letters, those letters can again be arranged differently. Yes. So for that we have to use permutation. So here, but each combination has 5 different letters, and those letters can be arranged among themselves in 5p 5 ways. Okay. So therefore the required number of words will be number of combinations into the number of arrangements that can take place among those 5 letters. Okay. So you will get this 25,200. Okay, next question. ISC 2020, 2 marks. In how many ways can the letters of word mother be arranged to form words beginning with T? So here mother, if you see, this word has got 2, 4, 6 letters. Okay, and here all letters are different. And here the question is how many words you can get, okay, starting with T with these letters. So here mother, there are 6 different letters and the letter T is kept fixed. So we have only 5 different letters to arrange, and it can be done in 5p 5 ways. So 120 words you can get, okay, or arrangements where the words will be starting with T. Next question is ISC 2020, 6 marks. How many different arrangements can be made from the letters of the word significantly in such a way that all the vowels are together? Okay. Number 2, all the vowels are not together. Okay. So one word is given to you significantly. The question is find the total possible arrangements, okay, where vowels are together, and in the second where vowels are not together. So here significantly, here you can see 13 letters are there, and I occurs 3 times and N occurs 2 times. So the total possible arrangement will be 13 factorial 13 upon factorial 3 into factorial 2. Okay, solve it, you will get. Then we will find how many arrangements will be there in which vowels are together. So firstly we'll find how many vowels are there. So we can see that vowels are A and I. Okay, but here we have to consider this to be as a single letter. Okay, because we want to know the number of arrangements where vowels are together. So we'll put A I as a single letter. Okay, now we'll count how many letters are there. Okay, best thing is just put this AII as X. So after that we'll have 10 letters. Okay, where you will see that N is occurring 2 times. So then total possible arrangements will be total possible arrangement for these 10 letters will be this factorial 10 upon factorial 2. But here you can see that AII, okay, these will again arrange themselves. Okay, so here AII can be arranged in factorial 4 upon factorial 3 because altogether there are 4 letters and I is repeated 3 times. So factorial 4 upon factorial 3. Okay, therefore number of words with vowels together will be given by this. Okay, so number of possible arrangement for these 10 and for these vowels among themselves. So you have to take the product and you will get the total number of arrangement where the vowels are together. Okay. Now we are looking for number of words where vowels are not together. So that would be equal to total possible arrangements minus total arrangements where vowels are together. Okay. So you just put the values and you'll get the answer. 4 marks question. Okay. I said that this was question 6 marks. So it is not 6 marks, it's 4 marks only. So these two question A and this question B, they had come in odd part. Okay, so either you do this or this. So these two are 4 marks. Now the question B says a team of 5 members is to be formed from 5 men and 6 women. Okay, so in how many ways can this be done if the team should consist of at least 3 women and number 2 at most 3 women? So a team has to be selected, okay, where there would be 5 members, okay, and selection has to be done from 5 men and 6 women. Now the condition is, suppose you're supposed to have at least 3 women, okay, then in how many ways you can do the selection? Okay, so here he's saying at least 3 women, so you can have 3, 4, 5 women, 6 women in fact, because total number of women are 6. So minimum you can have 3, you cannot have less than 3, so you can have 3, 4, 5, 6 women. Yes, so and here, but here the team member should be 5 only, so you can go 3, 4, 5. Okay, number of men 5, number of women 6, team must have 5 members. So number 1, at least 3 women, that is not less than 3. So number of ways the team can be selected, okay, when you are supposed to have at least 3 women, can be done this way: 3 women, 2 men, or 4 women, 1 man, or 5 women and no men. Okay, so you can just solve it, you'll get 281. Next is at most 3 women. Okay, that means you cannot have more than 3 women. You can have no women, okay, or less than 3, but no more than 3. So you can have 0 number of women, 1 woman, 2 women, 3 women, okay, but not more than 3. So here number of ways the team can be selected will be this. So 3 women, 2 men, 2 women, 3 men, and here 1 woman, 4 men, no women, 5 men. Okay, so these are the possible cases. Now you solve it and you'll get 381. So this is all for the lecture, and this chapter also gets over here. Okay.